All right, so we got an optimization problem working with problem where you've got a vertical pole that's 6 meters tall and another vertical pole that's 14 meters tall, and you've got 20 meters of ground in between them. And we have a wire that goes from one pole down to the ground and up to the other pole, and we want to find the minimum length of the total wire. So when I think about the length of the wire, I can see that it comes from two different right triangles. And so we have here an unknown length, x, and here the remainder, 20 minus x. And so what we're going to do is set up our right triangles and then find the minimum length. So the first one is you can do a squared plus b squared equals c squared. So you take the square root of that to be the length of the first chunk of the wire, like this length right here. And then the second chunk of the wire, which is the square root of a squared plus b squared. So if I simplify that out a little bit, I get the square root of 36 plus x squared plus the square root of 400, 20 times 20, minus 40x plus x squared plus 196. So then we take the square, or not the square root, we take the derivative of that. And so the derivative is going to be 1/2 times 36 plus x squared to the negative half times 2x plus 1/2 times 400 minus 40x plus x squared. I should have combined that, plus 196. So next step, I'll combine these together to the negative 1/2 times negative 40 plus 2x. We want to set that equal to 0. So what I'm going to do is multiply everything by 2 to get rid of my 1/2s. And then I'm going to get each term written in square roots and written in fractions. It's a lot easier to solve when you've got things written back into sort of their normal way. So 2x over the square root of 36 plus x squared, and then plus negative 40 plus 2x over the square root of, maybe it's easier to keep it like this, 20 minus x squared plus 196. I'm kind of undecided about which version of that is easier. So then what I can do is, if this is equal to 0, I can cheat a little bit and just sort of subtract this second piece from both sides and make this into an equal sign where I subtracted this from both sides of the equation. So I'm going to multiply, cross multiply here. This goes there, this goes there, and I'm going to distribute the negative like that. So I just moved one piece to the other side of the equation, and then I'm cross multiplying. So I have 2x times square root of 20 minus x squared plus 196 equals 40, positive 40 minus 2x times square root of 36 plus x squared. And then I'm going to square both sides. So if I square this left side, I can distribute it to both pieces. Same idea if I square the right side. So here I get 4x squared times 20 minus x squared. Oops, 20 minus x squared like that. I got some extra parentheses here. So 4x squared times 20 minus x squared plus 196. And over here, I have 40 minus 2x squared times 36 plus x squared. I'm just trying to see if there is any nice trick I can do. And what I'm noticing here is that the 20 minus x is really similar to 40 minus 2x. So let's do a little bit of distribution, but not too much. So I'm going to distribute here and here. So I have 4x squared times 20 minus x squared. And then I have to do 4 times 196. Let's see. Oops. 4 times 196 is 784. And then not plus equals 40 minus 2x squared times 36 plus, actually I'm not going to distribute that out. What I'm going to do is something slightly different. 40 minus 2x is the same as 2 times 20 minus x. What I'm trying to do is trying to keep something that looks similar, and I'm noticing the 20 minus x squared is showing up. And so I don't want to distribute it out and lose that similarity, because then you just have this big string of things and it's easy to kind of lose track of what's going on. So I'm going to bring this term over to the right side and then see what we can do from there. So 748x squared equals, if I distribute this, I have 4 times 20 minus x squared times 36 plus x squared, and then I'm subtracting the other piece, 4x squared times 20 minus x squared. Beautiful. Now we can write this. 748x squared equals, they both have 4 times 20 minus x squared, and then the first piece has 36 plus x squared, and the second piece has minus x squared. So check out how that worked. They both have this in common. So this one has a 4 here and a 20 minus x squared there. And so then I was able to factor that out, leaving me with, inside the parentheses, just a 36 plus x squared and another x squared. And those cancel out really nicely. Okay, I think there's no way around it now. I need to multiply some stuff out. So on the left side, I have 748x squared. And on the right side, I have 4 times 36. So I have 144. And I have to expand out 20 minus x squared. So I get 20 times 20, 400, minus 40x plus x squared, just like before. Okay, so let's multiply that out. So 144 times 400 is 57,600. Actually, does 144 go into 748 before I do this? 748 divided by 144. No. Let's see. There must be an easier way. Let me backtrack here. 748 and 144, I bet I could like divide them both by something. Let's see. So 748 divided by 2 divided by 2. So I could divide it by 4. 748 divided by 4 is 187. So I can make this 187 x squared, and 144 divided by 4 is 36. Just trying to get my numbers smaller. Does 187 have any other nice factors in it? Let's see, it's not even, it doesn't divide by 3. Does it divide by 7? No. Divides by 11. So now we're kind of stuck. I don't know why. One thing I'm wondering about is why this problem, in the textbook at least, says it's a no calculator problem. Because these numbers are just disgusting. Maybe they made a typo with the numbers they were trying to do, because as I'm simplifying here, I'm using a calculator just to check like some of my multiplications. I don't know why you would be expected to do this without a calculator. Okay, anyway, moving it all equal to 0. At this point, it's not gonna, that thing is not really gonna factor. Does 151 divide by 13, or no? So this isn't gonna factor, and so you would just use the quadratic formula here, or solve it by graphing. So x is equal to negative b plus or minus the square root of b squared minus 4ac all over 2a, and whatever that equals. So very weird that this would be put on a no calculator thing. The most important thing for your purposes is that you understand the setup here, and that I took the derivative and set it equal to 0 there. That then I went through and solved, trying to find out where it equals 0, and that eventually I would use the quadratic formula to get an answer. I will throw away the minus answer because that's going to be a negative value, and I'll keep the plus answer, so it tells me a value in between there. So please comment, let me know if there's anything else I can do to help. Sorry this problem got so nasty. I expect there's some sort of a typo with their numbers, and they weren't quite thinking of how it popped out.